partial fractions. Objectives. First one, revisiting polynomials. Second, rational fractions and types. Third, definition of partial fractions. Fourth, steps to resolve the rational fraction into partial fractions. Revisiting the polynomial. An expression of the form an x power n plus an minus 1 x power n minus 1 plus so on plus a2 x power 2 plus a1 x power 1 plus a naught, where n belongs to natural number set n, an minus 1, so on a2, a1, a naught are real numbers and an is not equal to 0, is called a polynomial of nth degree in x. Let us recall some of the types of polynomials. F of x is equal to 5, called polynomial of degree 0, which is also called constant polynomial. F of x is equal to 3x minus 2, called polynomial of degree 1, which is also called as linear polynomial. F of x is equal to 3 into x power 2 minus 4x plus 5 is called polynomial of degree 2, which is also called as quadratic polynomial. F of x is equal to 2 into x power 3 minus 3 into x power 2 plus 1 is called polynomial of degree 3, which is also called as cubic polynomial. F of x is equal to 3 into x power 10 plus x power 8 plus 3 into x power 2 minus 1 is called polynomial of degree 10. Real polynomial. A polynomial of nth degree is called real polynomial if all the coefficients are real numbers. For example, f of x is equal to 2 times x power 2 plus 5x minus 3 is a real polynomial since all the coefficients are real numbers. Complex polynomial. A polynomial of nth degree is called complex polynomial if at least one of the coefficients is a complex number. Example, g of x is equal to x power 2 minus 2i times x plus 3 is a complex polynomial since 2i is a complex number. Reducible and irreducible polynomials. A polynomial is reducible if it can be expressed as product of two or more real polynomials, otherwise it is irreducible. For example, the polynomial p1 of x is equal to 2 into x power 2 plus 5x plus 3 can be written as product of two real polynomials. So this polynomial is called reducible polynomial. The polynomial p2 of x is equal to x power 2 plus 4, which can only be written as product of two complex polynomials but not real polynomials. So this polynomial is irreducible polynomial. Division algorithm of polynomials. Let us recall the division algorithm of natural numbers. Suppose 12 is dividing 71. 12 times 5 is 60. 71 minus 60 is equal to 11. So we write 71 is equal to 12 times 5 plus 11. Here 71 is dividend, 12 is divisor, 5 is quotient and 11 is remainder. The property of the division algorithm is also applicable on polynomials. While dividing the polynomial f of x with another polynomial g of x, there exists one more polynomial q of x. Result is another polynomial r of x. F of x is called dividend, g of x is called divisor, q of x is called quotient, and r of x is called remainder. If f of x and g of x are two polynomials where g of x is not equal to 0, then there exists two polynomials q of x and r of x, such that f of x is equal to g of x into q of x plus r of x. Note: if f of x is of degree n and g of x is of degree m, n is greater than or equals to m, then q of x is n minus mth degree and r of x is of degree less than m. Remainder theorem. If a polynomial f of x is divided by a linear polynomial x minus a, then the remainder is f of a. Note: if f of a equals to 0, then f of x is divisible by x minus a. Let f of x is a polynomial, g of x is also a polynomial, and g of x is not equal to 0. Then the ratio f of x by g of x is called rational fraction. Example: 2x plus 3 is a polynomial, and x power 2 minus 2x plus 1 is also a polynomial, and x power 2 minus 2x plus 1 is not equal to 0 implies x is not equal to minus 1. Then the ratio of these two is called rational fraction. The definition of rational fraction is: if f of x and g of x are two polynomials and the denominator g of x is not equal to 0, then the ratio f of x by g of x is called a rational fraction. Proper rational fraction. A rational fraction f of x divided by g of x is called proper rational fraction if degree of f of x is less than the degree of g of x. Improper rational fraction. A rational fraction f of x divided by g of x is called improper rational fraction if degree of f of x is greater than or equal to degree of g of x. Definition of partial fraction and steps to convert fraction into partial fractions. Partial fractions. Recall that a rational fraction f of x by g of x is called proper rational fraction if degree of f of x is less than the degree of g of x. If a proper rational fraction is expressed as the sum of two or more proper fractions, then each proper fraction is called a partial fraction of the given fraction, where denominators are powers of irreducible polynomials. Note: the quadratic expression ax power 2 plus bx plus c, if it cannot be expressed into product of linear factors, reason b power 2 minus 4ac is less than 0. Example: consider two proper fractions, say 3 by 2x minus 1 and minus 1 by x minus 2. Their sum equals to 3 into x minus 2 plus minus 1 into 2x minus 1 whole divided by 2x minus 1 into x minus 2. Further simplification, we get x minus 5 whole divided by 2x power 2 minus 5x plus 2. which is a proper fraction. Thus, sum of two or more proper fractions is also a proper fraction. Writing the equation on reverse, the proper fraction x minus 5 whole divided by 2x power 2 minus 5x plus 2 can be expressed into sum of two proper fractions is called resolving into partial fractions. In this equation, on the right side, the two fractions are said to be partial proper fractions of left side. Steps to resolve given fraction into partial fractions. Step 1. Identify if the given fraction is proper fraction or improper fraction. Step 2. If it is improper, first convert it into mixed fraction by division. Step 3. Convert the denominator into product of linear or quadratic factors. Step 4. For the proper fraction, frame equation of partial fractions with arbitrary coefficients a, b, c, etc. as per the given table. Step 5. Solve for the coefficients by equating numerators of the equation of partial fractions. Step 6. Substitute the coefficients in the equation of partial fractions and verify.